Hi guys, this is A Plus Tutoring. In this recording, it will be a part 2 of the session I had with the student on organic chemistry, functional groups, IUPAC naming and isomers. So we'll now be dealing with the past paper where we'll be attempting the question on the naming. So, what do you see here?
I see one compound with a tall bond has branches. Its chain is 1, 2, 3, 4, 5. Wait, is it 1, 2, 3, 4, 1, 2, 3, 5, 1, 2.
And remember that your longest chain always has to include this, because you already saw that as your functional group, right?
Oh yeah.
So let your longest chain include that functional group. So now if you're to choose, for example, 1, 2, 3, 4, 5. Okay, we also have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You see, your longest is always going to be a 5.
Yeah.
Okay, so meaning now our longest is
5.
5, which is pent. Right? Now, once we choose, okay, our longest is now a 5. We now need to name it, and we're choosing the. Remember, we're choosing the longest from the closest. Yes, to the functional group. Now we need to name. Okay, what's the position of the branches? So since this is the same as me going like that, and it's the same as me going like that, so let me just take the easiest and take this one, right? As my main, right?
Yeah.
Okay, so let me use a different color. So this is my carbon 1, right? My carbon 2, my carbon 3, my carbon 4, and my carbon 5. Okay, now we need to name where is what, right? So you have branches. What kind of branches do you have?
Alkenes. Single.
Yeah, you always have single bonded branches, but what kind, as in the name of the branches?
Oh.
How many carbons do they have?
They have 1. They both have.
Meaning it's a methyl, right?
Yeah, methyl, yeah.
Right? So I have a methyl on position 2.
And 4.
But on position 4 we have 2 methyls. Okay, so meaning we write it twice. We have 4 and 4. So now in total, how many methyls do we have?
3.
3. And 3 is tri.
So first I write all of the positions of all of them. It was 4, 4, then together it's 5.
Tri. Yes. So the only reason we are combining them is because they have the same name, right? It's unlike if one was a methyl and the other was an ethyl. Then I'd have to say I have a 2 methyl, and then I go and I say I have another 4 ethyl. I don't combine them because they are differently named. So in this case I combined them because they are the same name.
Yeah.
So you see here they had the 2. So our answer will be what? It's a 2, 4, right?
2, 4, 4.
Yes.
Tri.
So meaning we are looking at these 3, right?
Yeah.
I mean these 2 answers. So we have a 2, 4, 4 trimethyl. 2, 4, 4 trimethyl. Now let's see. Our pent is in what position?
Position 2.
Position 2. So you always name the smallest, the closest carbon, the first carbon rather. So it's in between 2 and 3, meaning we name it on 2. So meaning your answer will be 2, 4, 4 trimethyl pent 2 in. Okay. Our next one is now this. Now, before we answer the question, I just want us to go through each, right? Let's jot down what we can on each compound, right? Okay. For example, A. What's the functional group of A?
Functional group. It's No, it's not an aldehyde. Ketone.
It's a
In the
ketone.
middle.
There you go. It's a ketone. And what's the position? What's the longest chain?
1, 2, 3, 1, 2, 3, 4, 5, 1, 4, 5.
5.
Yeah.
5 C's. Okay. And what's the position of the O?
1, 2, 3.
3. And then do we have a branch
Yeah.
on position?
4.
4. And our branch is a
methyl.
methyl. Okay, we move on. This one, it's a smaller thingy of what? What does it look like? If we were to continue doing the same thing over and over and over, what will we have? What functional group?
Won't it just be an alkane?
Yes, it's an alkane. So this is called a monomer, right? A monomer is actually smaller. A monomer is just like the C and that, and then with an H here, an H there, and then just that N, right? But then that's also a monomer. So what they mean by this is the fact that you're gonna, since they put an N, right? And N means that even if I'm to say 5 times of these, I'm just gonna continue going C, 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 C. You get it, good? I'm just adding the very same thing over and over and over again. So it's somewhat just telling me, good, okay, what you have here is what you will have in the bigger compound.
Wait, let's say the N, they say 2. So now will it be 4? Will it be 4 carbons in total?
Yes, because this one has 2 carbons, right? So if they were to give you the NS2, that would mean that it will have 4 carbons. It's 2 times of what you have.
Okay.
Okay.
Yeah.
So now, if we were to go to the next one, we have what? What do we have here? You first look for your functional group, ne?
I see alcohol.
You see an alcohol, okay. So we have our longest chain.
1, 2, 3, 1, 3, 1, 2, 3, 3.
3. So we have 3 C's in our longest chain, right? Remember that an alcohol also works the same as how we were naming here, to name with the position of the OH, right?
Oh, okay.
Yeah, so you also need a position of the OH if it happens. But in this case, since it's a 1, 2, 3, yeah, you need to say it's a 1 because it could be in a 2 position, right?
Yeah.
So you need to say it's in a 1. Okay, so do we have any branch?
Yeah, on position.
Okay, we have a branch on where?
Position 2.
Position 2. And what's our branch?
Methyl.
A methyl. Okay, so by you doing this, you're making it easy for you to name it when you finally get to the question. Right? Okay, so now we go to this one. What's your functional group?
I see an alcohol.
It's also an alcohol. Okay. Okay, the longest chain.
1, 2, 3, 4. 1, 2, 3, 4, 4.
4 C's. Okay.
Yeah.
What's your position of the alcohol?
Position 2.
Position 2. Okay. And then do you have any branches?
Yes, also on position 2.
Also on position 2. And it's a what?
It's a methyl.
It's a methyl. So everything is on position 2 and it's also a
methyl.
Okay. Okay. Now we move on to our next 2. So this one you're already given the name, right?
So butane.
Yes. We need to draw it.
But 1, 2, 3, 4.
4.
4.
Okay.
Bonds. No branch.
No branches. So it's somewhat like this with my lines being my edges, right?
Yeah.
Okay. Let me just write them.
No, you don't have to.
I don't have to. Okay.
Yeah.
Let's move on. This one?
That's an alkyne.
Alkyne. Okay.
Yeah.
It's an alkyne. Okay. How many C's?
4.
4 C's. Do I have any branches?
No.
Position of the alkyne?
Position 1, 2.
Position
2.
Position 2. Yes, so it's on position 2. Right? Okay. And then this one, ethyl propanoate. What is it? So I'm gonna now tell you what's an ethyl propanoate. The moment you see the noate part, it's an ester. Right? And an ester, once you get to, I don't know if you guys have already started reactions.
Yeah, we have.
An ester is a combination of an alcohol and a what? Let me erase this part. An ester is a combination of an alcohol and a carboxylic acid. Right? So, this name that you have here, it's 2 things. The first part is the alcohol, the second part is the carboxylic acid. So meaning how you draw it, you know you have an ethyl, meaning the alcohol is how many? It's an eth, how many?
Eth is 2.
It's 2. Meaning for the alcohol I have 2 C's, and then this one, there is my O, right? Because remember for an ester the O is in the middle, right? Okay, so meaning now I'm starting at the C. So this side is now the carboxylic acid, meaning it's how many C's?
Carboxylic does have.
Since here it's what? It's prop. It's prop.
Oh, prop.
How many?
Oh, 3.
3 C's, meaning I have 3 C's, right? But because it's the carboxylic acid, remember carboxylic acid has a double O.
Bond. Oh, yeah.
So this is now your ester with everything else being H's.
Can we go through that one more time?
Okay. Okay. So an ester, right? An ester is a combination of an alcohol and a carboxylic acid. So the first thing on your name is the alcohol. Right? The second thing is now the carboxylic acid. So now your alcohol, that means that technically I added, let's remove the "il" and put the alcohol's name. So it's an eth, meaning it's an what? Ethanol. Right? And then for the propanoate, meaning it's a propanoic acid. A carboxylic acid always has that acid name at the end, meaning it's a propanoic acid. Right? So noic acid. By me doing this, it's not telling me that, okay, so the first 2 C's that I have, they have to be joined to an O because they're the ones with the alcohol, right? And then the next 3 C's that I have, the first one is the one joined with an O. Why? Because for an ester, remember that for an ester, let me try to change the color. Something different. For an ester, this is the functional group, right? So the moment after putting the O for the alcohol, you know the next C that is coming has to have the double O for the carboxylic acid, and then the rest can now have the H's and everything. Now that we are done with dealing with everything, all the compounds, right? Now let's start answering our questions. So they now say write down the name of the homologous series to which compound F belongs. You see, by you writing, you've already answered.
Name of the homologous.
So when they say homologous series, right? Homologous series, they're just asking to which functional group.
It's serious.
Yes, so these names of saying it's an ester, it's a carboxylic acid, it's an alkane, those are homologous series. So they're just asking you to which compound does F, like what functional group is F under?
Oh. Wait, so if they say the name of the functional group, or they can say what is the form a longer series. So it's the same thing.
Yes. And then they now say name the functional group of compound D, right? Okay. So now let's go back to compound D. Okay. What did we say D was?
D was an alcohol with its 1, 3, 4. It's but.
We're not naming it. They want the functional group.
So the functional group is not an alcohol.
It is alcohol.
Oh.
So it is now an alcohol, right? So on the functional group, if you're going to name it, you just name it as an alcohol. But then at the same time, this is the one that I say that maybe you can draw it for them if you like. So you now draw your C with your OH.
Oh, okay.
So now the functional group of an alcohol is the C with an what?
OH.
Oh, let me just draw it here. It's a C with the O, H, and then that.
Okay.
So remember there's a bond between O and H.
Oh, yeah.
Okay. So now we move. Later that represents a primary alcohol. Which one is our primary alcohol? How many alcohols do we have in the list?
We have 1.
How many alcohols?
1.
Are you sure?
Indeed.
No, I said in the list. Remember now they want, the next question is saying, question 2.1.3, later that represents a primary alcohol. Now you now go back to all of them. You're now checking. That was a ketone. A was a ketone.
Oh.
B was an alkane, so they're out. C was an alcohol. D is an alcohol. E is a butane, so it's out. You see?
So it'll be C. It'll be C.
C. Why?
Yeah. Connected to one carbon.
Yes. It's the carbon that it's connected to is only connected to one other carbon. Right?
Yeah.
Yes, so it is a primary. So it is C. Okay, now they say the IUPAC name of compound A. Now we go back to compound A, right? You see how it made it easy by the fact that we labeled what it is, we labeled our longest chain, and where we have our
methyl.
So now the IUPAC name is you now naming it. What would you name this?
So we start it's 1, 2, 3, 4, 5. That's pent.
It's a pent, yes.
Yeah.
Okay, so we know it's a pent.
Then we look at the is the function group. CO.
It's on the functional group is on position 3, right?
Yeah, which is like the carboxylic acid.
Meaning we have 3. No, we did name it here. Remember?
Oh, ketone. It's ketone.
So it's on position 3, meaning it's the pent 3 on, right? But then there's something we left out. That methyl. Where
methyl. Where does the methyl go before or after everything?
A branch always goes before the main chain.
Oh.
So now you need to take your position of the branch. Yes.
Methyl. So we start with the 2 methyl.
Yeah, you could take 2 methyl. Yes. Since this functional group name doesn't matter from which end I start with, it's still a 3, right? So you can now start at the closest end of the branch.
Wait, was it gonna matter if it was 1, 2, 3, 4?
Yeah, they would kind of mark it wrong if it was 4, because the rules say if you first choose the position of the functional group, right, the closest to the functional group, right? In this case, the functional group doesn't matter from where I start. The functional group is always on a 3, right? So now after that I now choose the closest to the branch.
Oh, that's how you work.
Yes. So unless if I could start from the closest to the branch, the functional group would be moved to maybe a 4, then I'd have to consider the functional group before the branch. But in this case, the functional group stays the same despite where I start. So now I consider the branch and I say this is the closest to the branch.
Oh, okay.
So now it would be what?
2. Okay. Wait, is that the whole?
Yes, this is the whole name. So it will be 2-methyl pent 3 on.
Wait, what? Oh, that's the IUPAC.
That's the IUPAC. So an alkane plus oxygen is always supposed to give you CO2 and H2O. Always.
Oh, okay.
It always gives you CO2 and H2O. So now when they say a balanced equation, you now just have to write, since this one was a butane, right? A butane, what is the formula for butane? Let's count, how many C's do we have?
C4H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So we have that, right?
Yeah.
Okay. So now, let me try to see if I can find a clean page. Let me go back to this one. Yeah, there's a clean page. So we now have C4H10, right?
10.
Plus oxygen. And it should give us carbon dioxide plus water. So now when they say a balanced chemical reaction is what I have on the left should be equal to what I have on the right. So this side I had 4 carbons, right?
Yeah.
And this side, the only compound that has carbons is the CO2, right? Meaning I need to make it 4. Why? So that I can have my 4 C's. Do you see that?
Yeah.
So now on the left I now have, if I'm to put a line, I now have my 4 C's, right? And then how many O's do I now have?
You have 8.
I now
9.
have 8 O's from this one, right? Plus 1 O from that, which will give me 9, right?
Yeah.
Okay. And then H's?
H's, we have 2 on this side.
I have 2 on that side. So this side I now have my 4 C's, but I have 10 H's and I have 2 O's, right?
Yeah.
So let me try balance the H's first. Since this side I have 10 and that side I have 2, for me to balance it I need to times this by what?
5.
By 5. So I put a 5 there. Now that, do you see that that 5 now changes? Here I now have 10 and then it also changes the O's here. Okay. So now I now have how many O's plus how many O's this side? 5, right?
Yeah.
Plus 5 O's, which gives me?
Yeah, 13.
13. Okay. And then now I have my 10 H's, right?
Yeah.
Okay. Now this side, how do I now balance 13 O's and 2 O's?
Bone tree and
because this is the only O I have. So I technically need it to be an even number, because if I say maybe 6 times 2 will give me 12, which is still less. If I say 7 times 2 will give me 14, which is 1 more. So you see that I'm gonna have to try and balance, meaning I can try and say 2 this side. That's where you get marks by balancing. So if I say 2 this side, right, I'm now changing that to go and say that, okay, so that means I'll have 8 here, because this makes it 8 here, right?
Yeah.
Once I have 8 there, I now have how many H's? 20.
20.
Meaning I now go and I say
10.
10 there. And then now I see how many carbons do I now have?
You have 8 carbons. Wait.
This side I haven't named it. I haven't put my carbons yet this side, because I still want to balance this side, right? So I now have my 8 C's. I have my 8 Cs, right?
Yeah.
I now have 20 hydrogens. This side I also have 20, right? Now let me do the carbons. I have how many here?
Carbons, where don't we have 8?
8 times, remember this is a O2, so it's 8 times 2 because it already has 2. So I'm just saying I have 8 of those that have 2, meaning I have how many?
Oh, I thought you were talking about carbons. We've been saying carbons, not oxygen.
Sorry, oxygen, sorry.
Yeah.
Okay, and then this side, how many oxygens do I have?
10.
10 oxygens. So now I have how many oxygens in total?
26.
26. So I now have 26 oxygens, right? I now go this side. For me to get the same 26, I need to have how many here?
13.
13. So now it's balanced. Once it looks like this, it's now completely balanced because what you have on your left, you have on your right.
Right.
So briefly explain why a compound C and D are classified as positional isomers. What would you say? They told you already which ones are isomers. Now you have to explain why.
Why? Let's see why they are positional isomers.
Why C and D are positional isomers?
Do I have to talk about positional isomers?
Of which in this case I would battle with them as well, because these are not positional isomers. Because if you look at C has how many? 1, 2, 3, 4 in total, right?
Yeah.
Wow, D has 1, 2, 3, 4, 5 in total. That's completely different.
Wait, the question was,
explain why they are positional isomers. So positional isomers have to have the same.
You have to be 4 or 5 thingy.
Yes, they have positional. If they're isomers, once they're isomers, they have to have the same number of carbons, same number of hydrogens and everything. Just that the functional group can be at a different position or stuff like that.
Oh.
So in this case, looking at it, this one already has just 4. This one now has 5. That's completely different.
Oh.
Unlike if they had removed this, then I would support them by saying they're isomers. If they had removed that, then this one would be a primary, while this one it's a secondary, by saying that this one, yes, they're positional isomers. This one was on number 1, while now it's on number 2. And they can also be considered chain isomers if I had removed that, because now you see this one was, the longest chain was 4. Now here it's 3 with a branch.
But probably that doesn't. So
now that would also be considered now a chain isomer.
Oh, okay. Wait, so fine. Let's say they are both 4 or 5. So now, how would you like put that when they say play for 2 marks?
Okay, so now you need to explain that in compound C, the functional group of the alcohol, the OH, was on position 1, while in compound D, it was on position 2. You already separated by saying, yes, they have the same number of carbons, same number of hydrogen, but the position of the OH is different from C.
Oh, so the position of the functional group is on. So now you just have to the 2, but they still have the same number of carbon and hydrogen.
Yes, you're now just comparing the 2 by the position of the functional group.
Okay. Okay.
So now if it was a chain, if let's say you're talking about the chain length, right? You'd now have to say, okay, the longest chain in 3 is what? In C is 3 carbons, while the longest chain with a branch, right? While the longest chain in D is 4 carbons with no branch. That way it makes it what? A chain isomer.
Oh, a chain. Oh yeah. Oh, because now the carbons are the same, but the one has a one does. Okay.
Okay. Do you get it now?
Yeah, I get it.
Okay. Thank you for watching. Please do like, subscribe, and follow for more.